Start, sir.
Okay, sir. Welcome to our fourth session of surface chemistry. I already told yesterday the first preparation method for colloids. This is about the second preparation method for colloids. So here, second method is called Bradix method. Okay, this is called Bradix method. In this Bradix method, we have to use electrical disintegration. This is also called as electrical disintegration or Bradix arc method. In this process, we have to use this following matter like here. This process involves dispersion as well as condensation. That means what? This process is containing two steps. Number one is dispersion step. Number two is condensation step. Okay. Colloidal salts of metal such as gold, silver, platinum, etc. All metals are prepared by this Bradix arc method. Okay. Here, these all metal colloids are prepared by this method. What is that? Electrical arc method. But how it is run this method? Here, the electrical arc is struck between electrodes of the metal immersed in the dispersion medium. That means what? Here, simple. Here, electric arc is struck in between the electrodes. Like these electrodes are called as platinum electrodes. Here, in these electrodes are immersed in the colloidal particles. Yeah, this is called what? Dispersion medium. This is a colloidal particles. This bath is called ice bath. Here, when we have to provide intensive heat, then the metals are produce the vapors. After forming the vapors, we have to use the condensation process. Here, I told here the condensation process. Okay, here it is condensation process. When you use the condensation process, the particles are formed as colloidal particles. The particles are formed as colloidal particles. That means what? The size is increases. Thus, we have to prepare the what? Colloidal particles by using Bradix arc method. Okay, so this is about the Bradix arc method. Next, here purification of colloidal solutions. Here the dialysis process. It is very important one. It is play the important role in our medical field, like purification of kidneys. Okay. Here first we have to discuss about the dialysis. What is the meaning of dialysis? The process of removing a dissolved substance from colloidal solution using suitable membrane is called dialysis. That means what? The process which remove the dissolved substances from the colloidal solution by using suitable membrane. What are suitable membrane here? Parchment paper, cellophane paper, and animal membranes. Okay, these all are suitable membrane. That is called semi-permeable membranes. Okay, by using semi-permeable membrane, we have to do the process like dialysis. In this dialysis, here the colloidal solutions are generally contains excess amount of electrolytes and some other soluble impurities. Generally, the colloidal solutions are containing excess amount of the electrolytes as well as some impurities. Which impurities here? Soluble impurities. Okay, so due to these all impurities and all other electrolytes, we have to use the dialysis process. In this dialysis process, here this is called a what? Here it is a dialysis operator. The dialysis operator is called as what? Dialyzer. Dialyzer is arranged look like bag. This bag is called dialyzer. Okay, in this dialyzer there is available, yeah, here it is, salt particle as well as here in dialyzer it is also containing the crystalloids. This is also called crystallites. It is also containing salt particles. This bag is merged in the water, where the water is present in the one vessel. This is called as vessel. The vessel is always flowing the water. That is what, with continuous flowing of water. Once I repeat you, with continuous flowing of water. Here the impurities like electrode or any other atoms or molecules are substances are thrown out into thrown out into water molecules. This process is called dialysis process. What happened here? This is called semi-permeable. Here it is acting as a semi-permeable membrane. Simple. Always continuous flowing of water molecules. The impurities like or soluble molecules are thrown outside from this bag into continuous, flowing of water continuous. Always this process is called dialysis process. In dialysis process, you have to use the semi-permeable membrane. Here only one thing is there, always water is continuously flowing. Without continuously flowing, there is not run the dialysis process. This is play the important role in our medical field, like purification of kidneys, right? Then properties of colloids. Here, this is important one, which are asked for 2-mark purpose in your IP level, right? What is the meaning of Tyndall effect? Before that, it is proposed by Tyndall scientists. Therefore, it is called Tyndall effect. According to Tyndall, when light enters a colloidal solution, it is scattered by the large-sized colloidal dispersed phase particles. Therefore, when light passes through a solution, we will be able to see the path of the light as a luminous beam. This is called a Tyndall effect. That means what? Simple. When light is passed here, when light is passed through the colloidal solution, then the light is scattered here. This scattered is observed by using microscope. Okay, the path of the light is called what? Tyndall effect. Tyndall effect. Always light is scattered. That path of the light is called Tyndall effect. This process is observed by using microscope. Okay, this is the first property of the colloids. Then Brownian movement. This is a kinetic property of colloidal solution. When a colloidal solution is examined by ultra microscope, the colloidal particles are seen to be moving in a rapid zigzag motion. This rapid zigzag motion of colloidal particles is called Brownian movement. Actually, you know already, always the colloidal particles are present in zigzag movement. This is one. Zigzag movement or irregular movement or irregular pattern. Okay, the irregular pattern or zigzag movement of the colloids are observed by using ultra microscope. Here, by viewing this diagram, we have to conclude always the colloids particles are present in zigzag motion or irregular pattern. That's why this type of movement is called Brownian movement. Okay, this is also discovered by Brownian scientists. Therefore, it is called as Brownian movement. Okay, next. Here, what is the meaning of electrophoresis? When electrical potential is applied across two platinum electrodes dipping in a colloidal solution, the colloidal particles move towards one or the other electrode. The moment of colloidal particles under an applied EMF is called electrophoresis. By using this one, what you understood? Very simple. When you apply the EMF forces, that is electrical forces across the two platinum electrodes, when the two platinum electrodes are merged in the colloidal solution, by applying electrical current, the colloidal particles are moved towards platinum electrode. By this means what? Just why the molecules or substance are moved towards electrode, because of there is a differences in between size of the colloidal particles and shape of the colloidal particles. The colloidal particles are moved towards platinum electrode by applying electromotive forces. That process is called electrophoresis. Okay, what about the electroosmosis? Here, if the movement of colloidal particles is arrested by some suitable means, the dispersion medium moves in opposite direction. Always here the dispersion medium moves in opposite direction. This phenomenon is called as what? Electroosmosis. Next, here what is a coagulation? Okay, in this case, here coagulation is nothing but what? Coagulation is a process of aggregating together the colloidal particles so as to change them into large sized particles which ultimately settle as precipitation. That means what? Simply we have to conclude only within one point: the conversion of colloidal particles into precipitation. Okay, are you observed, my dear students? The conversion of colloidal particles into precipitation is called coagulation. Okay, very simple. Conversion of colloidal particles into precipitation. That means what is the meaning of precipitation? Simply we have to use in daily life. This is observed in your laboratories, especially the formation of solid particles. Simply says what? The formation of solid particles are called coagulation or precipitation. Okay, so this is about the coagulation. It is also asked for 2 more purpose in your IP level. Okay, then here coagulation, one more another definition. Coagulation is the destabilization of colloids by addition of chemical that neutralize the negative charges. That means what? Coagulation nothing but it is a destabilization of colloids by addition of the any other chemicals, which are the chemicals are used to neutralize the opposite charges. It will neutralize the opposite charges. That process, that phenomenon also called as coagulation or solidification. Okay, then the chemicals are known as coagulants, usually higher valency cationic salts. For example, here aluminum is containing +3 valency. Here ferrous is containing +3 valency. These type of more valency atoms are shows the more coagulation. These which particles are containing more valency, those particles are form the more coagulation or are more participate in the peptidization. Okay, so then here the coagulation is essentially a chemical process. Actually, the coagulation is we discussed in chemical process, but not in physical process. Okay, But here, this diagram is indicating about the coagulation. For example, here, yeah, large, okay, large repulsive forces. Here, it is repulsed with this one, it is repulsed with this one. That's why it is nothing but what? It is indicating as the destabilization. It is indicating as the destabilization. To control the destabilization, we have to use the different chemicals to neutralize neutralize their atoms of colloidal particles, to which are converting into peptidization. Okay, so this is about the coagulation, right? Then here, define flocculation value. Very simple. The minimum amount of electrolyte in millimoles that must be added to 1 liter of colloidal solution, so as to bring about complete coagulation, is called the flocculation or coagulation. That means what? The minimum amount of electrolyte is used to form the coagulation or precipitation. That means what? The minimum electrolyte is used to complete the coagulation process. That value is called flocculation value. Simply, coagulation also called as flocculation, okay, or peptidization. Okay, then here, very important one, Hardy-Schulze rules. These all are related towards coagulation process. These rules are related towards coagulation process. These all points are explained by Hardy-Schulze scientist. Therefore, it is called Hardy-Schulze rules. Under this, the first one is oppositely charged ions are effective for coagulation. Just I told you, always opposite charged ions are effective for the coagulation. For example, there is available positive charge atoms. Then it is effective towards negative charged atoms. If there is available negative charge atom, it is also neutralized by the positive charge atoms or particles. Okay. Then second point, the coagulating power of electrolyte increases with increasing in the charge on the ions used for coagulation. For example, in between aluminum, barium, sodium, here aluminum Al is containing +3 valency. Al is containing +3 valency. Therefore, aluminum is participate in more coagulation when compared with the remaining barium as well as sodium. Because of barium is containing +2 valency, here sodium is containing +1 valency. Due to presence of the more valency of aluminum, aluminum is within fraction of second, it will forms the coagulation, whereas compared with the barium. Okay, here like that. For negatively charged colloids, these all are used for the negatively charged colloids. As well as here it is what? Here there is available negative charged particles. Here, like -4, -3, and -2, -1. Because of these all are containing negative charged particles. That's why these all are used for positively charged colloids. Here, whereas here plus valence is used for negative charged colloids, and minus valence is used for positive charged colloids. Always you have to remember only one thing: with the particles which are containing more valency, those all are participate in the more coagulation power. So this is about the Hardy-Schulze rules. Okay. Next. Here, what is peptidization? Here, the peptidization is a process of converting a fresh precipitate into colloidal particles by shaking it with the dispersion medium in presence of small amount of suitable electrolyte. The electrolyte added is called peptidizing agent. That means what? Very simple. The process, which are converting the fresh precipitation into colloidal particles. That means what? The conversion of precipitation into colloidal solution. Conversion of precipitation into colloidal solution is called peptidization. By addition of some chemicals, the precipitation is converting into colloidal solution is called peptidization. It is quite opposite to the coagulation. Whereas in coagulation, what we have observed here, in coagulation, the conversion of colloidal particles into precipitation, whereas here the conversion of peptidization is into colloidal particle. That's why the peptidization is quite opposite to the coagulation. Okay, my dear students, are you follow me? Right. Here, peptidization versus coagulation. This column, this step, that means this column is containing peptidization. This column is containing coagulation. Right. Apart from this peptidization, here the first point is peptidization is the formation of stable colloids in a dispersion medium. That means what? Always peptidization is formed in presence of the stable colloids. These peptidization is formed in the stable colloids. Whereas here coagulation is the gelling or clumping of the particles. That means what? Here peptidization is present in stable colloids. Here it is presenting in destable colloids. Okay. Then second point of peptidization. A precipitate is passed to a colloidal phase using an electrolyte. Here precipitate is passed to a colloidal phase using an electrolyte. Here you have to use electrolyte. Whereas here oppositely charged particles form aggregates which then settle down under gravity. Here actually the coagulation is formed by the oppositely charged particles by observing the gravity. By observing the gravity, there is formed the coagulation process. There is no gravity towards peptidization, but the gravity is plays important role towards coagulation process. Then third point of the peptidization. Here the third point is example, that is peptidization of silver iodide using a potassium iodide solution. That means what? Here peptidize the silver iodide by using potassium iodide solution. Whereas here in coagulation, example is the particles in milk can get coagulated to form yogurt. What is the meaning of yogurt? Yogurt is a chemical substance by using lactobacilli virus. Yogurt means what? By using lactobacilli virus to form the lactic acid. That process is called yogurt. That means what? Here yogurt is nothing but about to form the one type of the coagulation. It is a example under yogurt. It is example under coagulation. Okay. Then here emulsions. What is the meaning of emulsions? In previous class we discussed about the emulsions. Emulsions are nothing but what? Liquid. Here disperse phase is liquid, disperse medium also liquid. Both are in liquid. The type of phenomenon is called emulsions. For example, here definition of emulsions: the colloidal system in which a dispersion of finely divided droplet of liquid in another liquid. I told you just now, liquid in another liquid medium is called emulsion. Okay, guys, liquid is present in liquid. That means what? Disperse phase also liquid, disperse medium also liquid. That means what? Smaller quantity also liquid and a major quantity also liquid. That phenomenon is called emulsions. For example, here milk. Milk is a best example under emulsions, right? In milk, the droplets of liquid fat are dispersion in water. This is an example for oil in water type emulsion. Okay, so let's we discuss about the types of the emulsions. Okay, It is important one, the types of the emulsion, which is asked for 4-mark question in your IP purpose. And also very simple to remember it. That's why you have to more concentrate on these types of the emulsions. Okay, my dear students. Right, then here classification of emulsions. Here the emulsions are classified into two classes. These are number one is oil in water, which is represented by O slash W, and the second one, that is W slash O. That means what? Here A is a oil in water, but B is a water in oil. Here water in oil, here oil in water. Okay, here O is indicating as the oil, and similarly W is indicating as the water. Okay, O is indicating as the oil, the first letter O, and W is the first letter water. That is water. Okay, so right, these emulsions are classified as such depending on which is the dispersed phase and which is dispersion medium. That means what? The emulsions are classified based on the dispersion phase as well as dispersion medium. The first one we discuss about the first one here. Here oil in water. That means what? O slash W. Here oil in water. You have to understand me. You have to observe only one tip. The tip is there what? Oil in water. That means what? Oil in. That means what? Oil is a dispersion phase. Water is a dispersion medium. That's why this type is called oil in water. Oil in water. Oil is a what? Dispersion phase. Water is a dispersion medium. Don't confuse, my dear students. Okay. Here in this type emulsions, the dispersion phase is oil. Just I told you, dispersion phase is oil. That means what? Here oil is a minor quantity. Oil is a minor quantity, and the dispersion medium is water. That means what? Water is a major quantity. Water is what? Major quantity. For example, just I told you, milk or liquid and fats. Fats are nothing but here generally it is called as oils. Okay, milk, liquid, fats in water. Okay, so this is about the best example for what? Oil in water. And also there is a available another example, that is vanishing cream. Vanishing cream. Here in vanishing cream, fat in water. Fat in water. Vanishing cream. That means that look like, what is that? Nowadays we have to use in winter season Vaseline, like that. Vaseline. Okay. So in Vaseline, fat in water. Fat in water. That's why fat is a example under disperse phase, and water is example under disperse medium. Okay. Okay. Clear, my dear students? Right. This is about the oil in water type emulsion. Then let's we discuss about the second type, that is water in oil. Here in water in oil, here water in oil, right? Water in oil type emulsion. In this type of emulsions, the dispersed phase water and dispersion medium is oil. For example, stiff greases, water in lubrication, oil. In cod liver, oil. I mean what here? Simple. Here dispersion phase is water. Okay, dispersion medium is oil. That's why water in oil. Water in oil. That means what? Water is a smaller quantity. Okay, that's why the water is called as here dispersion phase. But here oil is major quantity. Oil is major quantity. That's why oil is called as here dispersion medium. Dispersion medium. Example is what? Cod liver oil or stiff greases. These all are example under water in oil. Water in oil. Okay, don't confuse. Don't confuse here. Slide change here only. Oil in water, first one. Second one is water in oil. So in important one. Okay, water in oil. and oil in water. So this is about the classification of emulsions. Okay, are you following, my dear students? And then yeah, applications of emulsions. It is very important one for your competitive purpose as well as your IP purpose also. Apart from this, that means what application of emulsion means what uses of emulsions. Uses of emulsion. Under this, the first point is in the digestion of fats in intestines. Okay, actually by using emulsification, here the fats are present in the intestines. There is no emulsion process in the intestine. There is no fats are dissolved in the intestine. To dissolve the fats in our intestine, there is available emulsification process. There is available emulsion process. Okay, so that's why the what is the digestion of fats in intestines? There is also use the emulsions process. Then second process is in washing process of cloth and crockery. That means what? Just we discussed in previous class. Cleaning of cloth. Okay, to form the micelles. That means what? Here there is also available. There is also uses the emulsion process. By using emulsion process, we have to purify the cloth. Okay, we have to recover the crockery of cloth. We have to use the recovery crockery of cloth by use of the emulsions. Okay, this is about the second point of the emulsion. Then third point here in the preparation of lotions, creams, ointments in pharmaceutical and cosmetics. In general, we have to this is about the very we have to see in daily our life. Okay, it is also apart from our life. Okay, here to prepare the lotions, to prepare the creams, to prepare the ointments. Okay, in this process, these all points are containing emulsion process. Emulsion process. Okay. Then next point, that is in the extraction of metals. Already in froth flotation, we have to extract the some metals. On that process, we have to use the emulsions. We have to use the emulsions, right? Okay. Then in the conversion of cream into butter by charming. That means what? The conversion of cream into butter. In this case, by using, we have to use the charming. In this process also, we have to use the emulsion process. Emulsion process, either it is oil in water type or water in oil type. Then here, the break oil and water emulsion in oil wells. Okay, in this process we have to use the emulsions. The last point of the application of emulsion is in the preparation of oily type of drugs for easy absorption to the body. This is also plays important role in medical field. Okay, that's why the emulsion process, the use of the emulsions also play the important role or key point in the medical field also to prepare the different type of ointments, medicine, capsules, whatever maybe. Okay, so this is about the main uses of the application of the emulsions. Okay, then here last one, that is applications of colloids. In this first one here, purification of drinking water. Purification of drinking water. Here we have to purify the water. We have to use the colloids. By using colloids, you have to purify the drinking water. Right. The second point is tanning. Here very important one. Tanning. What is the meaning of tanning here? It is also asked for 2 more purpose. Some question papers are containing this type of questions. Here it is tanning. What is the meaning of tanning? Tanning means what? To purify the skins, look like animal skin. To purify the animal skin, by purifying the animal skin is formed as the hardening the skin. hardening the skin. That is called as what? Leather. Leather, look like leather shoe, leather skin, like that. That process, the purifying of the skin, the hardening of the skin, that process is called tanning. Okay, that process is called what here? Tanning. Yeah, this is also best use of the colloids. On that process, we have to use the colloid process. Then here, the third point is to prepare the medicines. Here, medicine. To prepare the medicine, we have to use the colloids. To prepare the medicine, we have to use the colloids. There is available so many applications, so many uses are there, but among those, I have to highlight here only important one. What are those? Once again, repeat you here. The first point is purification of drinking water, and the second point is tanning. Third point is medicine. Okay, so this is about the what application or uses of the colloids. Okay, okay, this is about the surface chemistry. In this chapter, we have to discuss about the adsorption. Okay, we have to discuss about the adsorption, absorption, and then colloids, types of the colloids, as well as emulsions. Okay, so this is about the important task about the surface chemistry. Up to this, surface chemistry is completed. Let's we discuss tomorrow about the P block elements like 15 and 16. Thank you.